Hello, and welcome to Proving the Concept, the show where we explore the weird, wonderful, and sometimes bizarre world of science and technology. I'm Sarah Goffin, your guide through today's mathematical mystery tour. Today's episode is called Logging On. No, it's not about your favourite social media app or email woes. We're diving into the incredible world of logarithms. We'll trace their fascinating history, uncover their surprising connections to science, and explore some quirky facts along the way. Stick around until the end because we'll also highlight the story of a pioneering female scientist whose work is linked to this fascinating field. So, without further ado, let's get logged into logarithms. Let's start with the basics. What is a logarithm? Simply put, a logarithm answers the question, to what power must a specific base number be raised to produce another number? For example, log base 10 of 100 is 2, because 10 squared equals 100. Logarithms are a kind of mathematical shorthand, a concept that was revolutionary when it was introduced in the 17th century. The credit for this transformative tool goes to Scottish mathematician John Napier. In 1614, Napier published Mirifici Logarithmorum Canonis Descriptio, or a description of the wonderful table of logarithms. Back then, performing complex multiplications or divisions was painstakingly slow and error-prone. Napier's logarithms simplified these calculations, making life easier for astronomers, engineers, and scientists alike. But fun fact, Napier didn't stop with logarithms. He also invented the bones, a precursor to the slide rule, and introduced the use of the decimal point in mathematics, a true pioneer of his time. Following Napier, other mathematicians like Henry Briggs refined the concept, creating the common logarithm system, log base 10, that we use today. The field of logarithms exploded, and they became an indispensable part of scientific progress during the Enlightenment. You might be thinking, okay, logarithms sound cool, but how do they show up in real life? Oh, let me count the ways. Earthquakes and the Richter scale. When you hear that an earthquake is a 7.0, it's not just a random number. The Richter scale is logarithmic, meaning that each whole number increase represents a tenfold increase in amplitude. So, a 7.0 earthquake is 10 times more powerful than a 6.0. Music and sound waves. The decibel scale, which measures sound intensity, is also logarithmic. A small increase in decibels can mean a huge jump in loudness. Computer science. In algorithms, logarithms often help make processes more efficient. For instance, a binary search algorithm can cut down search times by eliminating half the options at each step. Population growth and radioactive decay. Logarithms are crucial for understanding exponential growth and decay in fields of biology, chemistry, and environmental science. And that's just scratching the surface. Logarithms have even inspired areas of art and design, thanks to their natural connection to exponential spirals found in nature. Let's lighten things up with some fun facts. Number 1. Slide rules. Before the age of calculators, slide rules were the go-to tools for scientists and engineers. These analog devices use logarithmic scales to perform complex calculations. The Apollo 11 mission to the moon? Yep. Calculations were done using slide rules. Number 2. The eccentric Napier. John Napier was also known for his eccentric personality. He believed in alchemy and reportedly owned a black rooster that he thought could sniff out thieves. Number 3. Logarithms in nature. Did you know that trees naturally use logarithms? Their growth rings expand in a way that follows a logarithmic pattern. And number 4. Online algorithms. The term logging on isn't just a fun pun for this episode. When computers process logs, as in server or error logs, they're organizing massive amounts of data into manageable scales, often using logarithmic structures to sort and search efficiently. Now let's take a moment to highlight an extraordinary mathematician who deserves the spotlight, Grace Chisholm Young. Born in England in 1868, Grace Chisholm Young broke barriers as one of the first women to earn a doctorate in mathematics in Germany. She collaborated with her husband, William Henry Young, on a wide range of mathematical topics, including logarithms and calculus. One of her notable contributions was the development of rigorous theories of infinite series and functions, areas closely related to the foundational mathematics of logarithms. Despite societal barriers, Grace published significant works under both her name and her husband's, a testament to her brilliance and resilience. Grace also wrote mathematical books for children, which were groundbreaking for their time, making complex concepts accessible to young minds. Her legacy reminds us that the world of math and science is better when everyone gets a seat at the table. And that's a wrap for today's episode of Proving the Concept. We've journeyed through the history of logarithms, marvelled at their applications, and celebrated the achievements of Grace Chisholm-Young. I hope this episode has opened your eyes to the power of logarithms and maybe even inspired you to explore more math in your everyday life. Thanks for tuning in, and don't forget to subscribe for more episodes exploring the quirky corners of science and technology. Until next time, I'm Sarah Goffin, reminding you to stay curious and keep proving the concept.